So in this question it is given that 1 gram of steam is sent into 1 gram of ice at thermal equilibrium. Resultant temperature of mixture is. So over here we are mixing 1 gram of steam and 1 gram of ice. So you can take it as 1 gram of steam at 100 degree Celsius. Its temperature is not mixed mentioned over here, but you can just consider that it is steam at 100 degrees Celsius is mixed with 1 gram of ice, and temperature of ice is also not mentioned over here, but we can just take it as something but ice at 0 degree Celsius. So we know that there will be a flow of heat energy from high temperature region to a low temperature region. So the temperature of this object is going to decrease, and temperature of this is going to increase. So we can just identify what is the next stage over here. So whenever there is a change in phase or change of state, you cannot directly consider that it is going to convert it into water. So you can just consider the next stage over here. So next stage over here, it is going to convert steam at 100 is going to convert into water at 100. So you can write this as water at 100 degree Celsius. Like that, on the right side, we can say that as we are supplying heat energy to ice, there is a possibility that ice may converted into water at 0 degree Celsius. So we are writing the possibilities. It is not necessary that steam is going to convert it into water, or it is not necessary that the entire ice is going to convert it into water. So to identify this on the both side, we can write how much amount of heat energy is required. So over here you can write m into L, mass into latent heat. Mass is nothing but 1, and latent heat of fusion of ice is 80, or you can say that we required 80 calorie of heat energy. Now on the left hand side also we can write the same equation. So we'll write Q is equal to nothing but m into L, mass is 1, and latent heat of steam is nothing but 540. That means 540 calorie of heat energy is required to convert steam into water. Then we can observe which process is going to happen. So as we are observing that for this process only 80 calorie of heat energy is required, and for this process 540 calorie of heat energy should be removed from it. So we can say that this process is going to happen, and this process is not going to happen. So we'll try to find out the next stage where the process is happening. So here we'll identify what about the next process, and here we cannot continue because this process not yet happened. So we can write on the right hand side what is the next stage. The next stage over here is water at 0 may converted into water at 100. So we don't know, there is a possibility it may converted into water at 100 degree Celsius. Then again we'll identify what about the value of heat energy required for this process. So we can write there is a change in temperature. We'll use this equation. Q is equal to ms delta T. M is 1, S is nothing but 1, and delta T is nothing but 100. So we can say that for this process 100 calorie of heat energy is required. So on the right hand side you can observe that the amount of heat energy required is 100 plus 80, that is 180, and on left hand side you can observe that it is able to provide 540 calorie of heat energy. So again we can say that this process will also takes place, and still this process is not happening. That means the entire amount of steam is not going to convert it into water, but the ice is converted into water, and then water is converted into water at 100 degree Celsius. Now we can observe that it is a mixture of steam and water at 100 degree Celsius. Now the temperature of this object and this object is same, so further flow of heat energy will not take place. So we can say that the equilibrium temperature is going to be 100 degree Celsius.